Lesson number 5. In this lesson, we will be talking about the cumulative problem, which will touch all the aspects of mole and mass interconversion and mole and Avogadro's interconversion, involving the volume of the gases and stuff. In relationship to the balanced chemical equation, all of them will be tested in one problem. So you can say that this is a recap of what we have learned in the previous lectures. The next learning objective will be, we will be going to understand yield and percentage yield or percent yield and how to calculate it. So let's get started. An example problem number 1, magnesium reacts with oxygen to produce magnesium oxide. What amount in grams of magnesium is required to produce 4.50 grams of magnesium oxide? How many number of oxygen molecules are required to produce 4.50 gram of magnesium oxide? So first we need to understand that we are provided with certain things. So this is our first thing to look into. We have to find out that what amount of magnesium is required to produce 4.50 gram of magnesium oxide. So this only works when we have a scale, and scale comes from the balanced chemical equation. So let's first find out what is the balanced chemical equation. In this, magnesium is actually reacting with oxygen and is producing magnesium oxide. So this makes the body of chemical equation. Magnesium, solid state, when reacts with oxygen, which is a gaseous substance, it produces magnesium oxide, solid. Now we need to balance the equation. Here we have only one oxygen on the product side, but on the reactant sides we have two oxygens. Why not to make it 2? And we will make it 2 here. So now the equation is balanced. This equation tells me that 2 moles of magnesium upon reaction with 1 mole of oxygen, it produces 2 moles of magnesium oxide. So first we need to find out that what amount of magnesium oxide is produced in this reaction. So we are provided with the grams. We need to find out number of moles. So number of moles of magnesium oxide, this is equals to mass divided by molar mass. This is the formula. So this means that if mass is given to us, we need to find out the MR first. So in order to find out MR, this should be our first step. So let's pull it down a little lower and we will be finding out MR first. So MR of magnesium oxide. This is equals to 24 cross 1. 24 is the atomic mass of magnesium, plus 16 cross 1. What do we get? Let's do a little maths here. The answer is 40 grams per mole. Now putting the values in the formula, what do we get? 4.50 divided by 40. We get 0.1125 moles. So we are going to find out that what amount of magnesium is required to produce this 4.50 gram of magnesium, which is magnesium oxide, which is 0.1125 moles. So we are going to do a little ratio. This shows a start of new step. So we are going to make a ratio magnesium oxide from the balanced chemical equation, which sets a scale. This one here is a scale to read. So scale tells me that 2 mole is reacting to produce 2 moles. This means that 0.1125, which are the number of moles of magnesium oxide, will be produced or require how much of oxygen, that is X. So direct relationship tells me that X is equals to 0.1125 moles, which are the number of moles of magnesium. Since they want the answer in grams, so we must convert this moles into grams, and for that, mass is equals to number of moles cross MR. All this information is coming from this triangle. This triangle is telling us that we have mass here, We have number of moles here and we have MR. Since I need to find out mass, if I make this as a subject, if this is the subject to work out my equation, so they are going to multiply together since they are in front of each other. So number of moles is multiplied by the MR. In here we have magnesium atom, so this MR would become AR. So times AR, which is 24. What do we get? We get 2.7 grams. This is the final answer that we need. In the next part, where how many number of oxygen molecule, now they are talking about number of oxygen molecule which are required to produce 4.50 grams of magnesium oxide. So number of oxygen molecule, this means that here they are talking about the way we discussed earlier, that one mole, this is equals to 6.02 times 10 power 23 molecules of any substance. So they are just asking about that what number of molecules of oxygens are basically reacting with magnesium to produce 4.50 grams of magnesium oxide. So again we are going to relate it with the moles, and we will be finding out that what amount or what number of moles of oxygens are required. So first we have to do the ratio, in which we have a ratio between oxygen and magnesium oxide. 1 mole produces 2 moles. So 0.1125 will produce X. So X is equals to 0.1125 divided by 2. What do we get? We get X is equals to 0.0563 moles. These are the moles of oxygen. Since 1 mole is equivalent to 6.02 times 10 power 23 molecules. So 0.0563 moles will be equivalent to how much? That is X. So X is equals to 0.0563 times 6.02 times 10 power 23. So what do we get? We get 3.40 cross 10 to the power 22 molecules of oxygen that are required to react with magnesium to produce 4.50 grams of magnesium oxide. So you see that in this whole problem, we have interrelated mole with the mass, moles with the moles in the balanced chemical equation, and moles and its relationship with the number of molecules and how those number of molecules are needed to produce certain amount of product. So in this cumulative product, we come up with all the aspects that we have learned in the previous lessons, and we touched that. So it's kind of a quick recap. Now let's move on to the next problem. In another experiment, 2.40 gram of magnesium was burnt in excess of oxygen to form magnesium oxide. Calculate the amount of magnesium oxide produced. So this is a bit of the same problem that we are doing so far, but in this we are going to learn another fact, and that fact is the yield. So first let us look at the yield. What is yield? This is the actual amount of product obtained during reaction. This yield is actually like this, but there are two kinds of yield. One is the actual yield, which is the actual amount of the product obtained during reaction. The other one is the theoretical yield. So what is theoretical yield? Theoretical yield is what we calculate theoretically on the paper. That is the theoretical yield. This is the calculated amount of product obtained on paper. Let's find out how. We had 2.40 gram of magnesium. We have excess of oxygen, so no need to worry about that. And we just need to find out that what amount of magnesium oxide this magnesium will produce. So again, we need a balanced chemical equation for the scale. So magnesium, when reacts with oxygen, it will produce magnesium oxide. So balance this. The equation tells us that 2 moles are reacting to produce 2 moles. This is 1:1 relationship. But first we need to find out that what amount in moles are there if we have 2.40 grams of magnesium. So again, we have to use a formula where a number of moles of magnesium will be calculated as mass upon AR. Since it's an element, not a molecule, so no MR, there should be AR. So mass is 2.40 divided by AR, that is 24. So what answer do we get? 2.40 divided by 24, we will get 0.1 mole. This means that if I do the relationship as in ratio, then magnesium ratio magnesium oxide. So 2 moles are producing 2 moles, so 0.1 will produce how much? That is X. This means that X is equals to 0.1 mole. If we give our answer in grams, then mass of magnesium oxide produced, this is equals to number of moles times MR, since it is magnesium oxide, a molecule. So this is equals to number of moles is 0.1 cross MR, which is 40. We have calculated here previously, you see. So 40 grams per mole. This is equals to 4 grams. So you can also see that you can't make a direct relationship between grams. So for this, you need to work with the number of moles in order to get the right answer. So we have this 4 grams that is produced in this. So this is this calculation that we have done. This actually explains or talks about the theoretical yield. This is actually the theoretical yield because we have done calculations to find out that what amount of this is produced. But in the very same above experiment, 3.82 grams of magnesium was obtained during the reaction. So what is the percent yield? Now, we have actual yield and theoretical yield. And I've told you that actual yield is the amount of product obtained during reaction. You see, it is produced during reaction. And theoretical yield is something you can relate here, that it is something that is produced after doing all such calculations. When we do all such calculations, we find out that this amount of substance should be produced. So that is the theoretical yield. But theoretical yield and actual yield should not be equal. And why is that? Because we are not perfect. We human beings, we are not perfect. There are many things that would decrease the efficiency of the work we do. It could be human error, it could be the spillage of the substances, or the reacting molecules are not completely reacted, and many other stuff that would decrease the yield. So actual yield should be less than the theoretical yield. We can make a statement that actual yield should be less than theoretical yield. And when we find out the percent yield, then that percent yield is actually the ratio of the actual yield over theoretical yield cross 100. We get the percent, so we must multiply it by 100. Like, out of that theoretical yield, how much of the actual yield you have obtained originally while performing the experiment is what actually talks about the percent yield. So actual yield should be less than the theoretical yield. So we have an actual yield which is 3.82. So let's find out the percent yield. This is equals to 3.82 upon 4 times 100. We get 95.5% yield in this experiment. So what about the 0.45% that is not being produced? So what about the 4.5% that is not achieved or retrieved during this whole process? There might be a process that the magnesium would be impure, and there might be a thing that oxygen is not available, so a less yield is obtained, or there might be a problem that magnesium oxide was left behind in the beaker and we just received or retrieved only 3.82 grams of magnesium. There are many factors that could decrease or lower the actual yield. So we must remember that the actual yield should be less than the theoretical yield. There is another aspect to this percent yield, and that is the percent yield is used to find the purity of the substance as well. See, why we are looking into that, because we have understood over here that the actual yield is actually lower than the theoretical yield, and there are many factors. There could be impurity, there could be leftover substances which haven't reacted, there could be spillage, there could be problem in reading, problem in measuring the grams at the start of the experiment or after the experiment. So there could be many reasons. So one of the reason or one of the aspect we need to look into, and that is the purity of the substance. That could be another thing which is used to find out that how much our substance is pure. So in this example problem 3, we will be finding out that how purity or impurity of a substance could be found out. So 3.46 grams of impure calcium carbonate decomposed to produce calcium oxide and carbon dioxide. 1.42 grams of calcium oxide was obtained. What is the percentage purity of calcium carbonate? So we need to understand that if the thing is mentioned to us that 1.42 grams of calcium oxide was obtained, this means that that was the actual yield. That was the actual yield, because this was what that was obtained. And we need to first find out the theoretical yield in order to find out that what percentage was there. So for this we need to have a balanced chemical equation. Calcium carbonate solid, which upon decomposition produces calcium oxide solid, plus carbon dioxide gaseous. So we see that the equation is all over balanced. So we need to find out that what amount of this calcium carbonate is in moles. So we need to convert it into moles. So first we need to calculate the MR. Calcium carbonate 40 cross 1 plus 12 cross 1 plus 16 cross 3. What do we get? This is 100 grams per mole. So number of moles of calcium carbonate, again we are going to use a formula, mass over mR. This is equals to 3.46 over mR, which is 100. What do we get? This is 0.0346 moles. So calcium carbonate ratio calcium oxide, 1 mole is producing 1 mole. This is actually the scale. This scale comes from the balanced chemical equation. So 0.0346 will produce how much? That is x. So x is equals to 0.0346, right? So we need to find out that what amount in grams are there which are being produced. So x is equals to, or you can say that the mass of magnesium oxide, mass of calcium oxide, I'm still in that previous example. So mass of calcium oxide, this is equals to 0.0346 times the mR. So mR is 56. How? Because if you look at the mR calculation of calcium oxide, this is 40 plus 16. This is actually 56 grams per mole. So 56, and what do we get? 0.0346 times 56. We have 1.9376, or you can say that this is 1.94 grams of calcium oxide that could be received. So we need to find out that what actual amount of calcium carbonate was there in the impure sample. So we will now be doing the reverse calculation. So if we do the reverse calculation, we will find out that for the production of 1.94 grams of calcium oxide, what amount of calcium carbonate was there? So, but since in actual yield we received 1.42 grams, which was not actually the amount which is near 1.94 gram, and there is one of the cause, that is we are receiving the lowest actual yield. The substance is not pure. So for this 1.42 gram, what amount of calcium carbonate is there, we will be looking into that. So we need to convert this 1.42 grams into the number of moles. We have 1.42 divided by 56. This is equals to 0.025 moles. So relating it with the amount of calcium carbonate present, so 1 mole, and 0.025 x, this implies that x is equals to 0.025 moles. In order to find out the mass of calcium carbonate that was there, this is equals to number of moles times mR. This is equals to 0.025 times 100, which is actually 2.5 grams. So this is the substance which was actually present in the impure sample. That is why we get the lowest actual yield. So we need to find out that what percentage was there. So percent purity, this is equals to actual mass of substance divided by impure mass of substance, or a mass of impure substance. You can write it like that. Mass of impure substance times 100. So percent purity, this is equals to 2.5 divided by 3.46. That was the gram originally taken, times 100. What do we get? This is 72.25 or 3% pure. So why did I haven't used a direct approach and I did one calculation first and then I did the other part? The reason only is that I just want to give you a clear picture that starting from the given number of moles, when you find out the yield of the product that is being obtained, this should be the theoretical yield which is calculated on the paper. But when we perform experiment in actual practice, we see that the amount obtained is less than the theoretical yield. So there could be many reasons. If we rule out the human error, then there could be the reason that the substance is not pure. So we need to find out that what amount of a substance was there which result in the production of the product that we have obtained in the actual experiment. So for this, we found out through calculation that for the production of 1.42 gram, what amount of calcium carbonate should be present in the impure sample. So we did calculated that, and then that was a reverse approach. And then we find out the percent purity to find out that what was there which is leading to the less amount or less yield of the actual yield. So this is how you relate the actual yield and theoretical yield with the percent yield with the percent purity of the substance. I hope you are clear about this. For any other assistance that you need, you'll be provided with the other practice problems on demand. Thank you.